And good morning, Math Masters and Math Wizards. We're going to continue to master fraction, subtraction, and addition. This is problem set 17, lesson 17, problem set, page 171. If you do have the problem set at home, if you don't, no big deal. You can just follow along with me using a piece of scratch paper. Number 1 says, use the following three fractions to write 2 subtraction and 2 addition number sentences. So those fractions are 8/5, and you can write these down with me. And when we list the fractions, we put the comma there. 8/5, 2/5, and 10/5. So they want us to create 2 addition and 2 subtraction sentences from these fractions, okay? So let's go ahead and get started, and we'll start off with, let's just do the first 2. 8/5 plus 2/5. What would that equal? Well, remember, the denominator does not change. And then 8 plus 2 would be 10. So we have 10/5. And remember how we did a number bond to determine what this would be as a mixed number? So we would say 5/5 and 5/5. Look at that. Lo and behold, 1 whole and 1 whole. So this would equal 2. Because we have 5/5 and 5/5 to make 10/5. And we know that 5/5 is 1 plus 1 is 2. Let's do another one. Let's do 2/5 plus 10/5. And what will that equal? Well, remember, the 5 does not change. And then we do 10 plus 2 plus 10 is 12. So what do we have here? We have 12/5, which is greater than 10/5. So let's see, let's break this down. And I think we're going to have to use 3 number bonds. So we do 5/5 plus 5/5 plus how many's left over? 5 plus 5 is 10, so there's 2/5 left over. So it looks like we have 1, 2, and 2/5. And then it says to create 2 subtraction sentences as well. So let's go ahead and do that. And we'll do 8/5 minus, oh, it must be math mutt, minus 2/5. That's going to equal what? Well, the 5 remains the same. 8 minus 2 is 6. And we break this apart. We have 5/5. And how many fifths do we have left over to get to 6/5? Well, just 1/5. So it looks like we'd have 1 and 1/5. And we'll do another one. Let's go back to our fractions here. Let's do 10/5. Let's do 10/5 minus 8/5, okay? And remember, you can always pause to catch up. And so I know that 5 will remain the same, and I have 10/5, and I'm taking away 8/5. 10 minus 8, 8, 9, 10 is 2/5. And there we have it. And conversely, if I want 8/5 plus 2/5, I would have 10/5. All right, let's continue on. Excuse me. And we have B, which has 15/8, 7/8, and 9/8. So this is what our worksheet wants us to make. 4 math sentences, 2 addition and 2 subtraction. Let's do addition first, and let's add 15/8 and 7/8. Well, the 8s stay the same, and then we have 15 plus 7. 15, 16, 17, 18, 19, 20, 21, 22. We have 22/8. So now I can break this down using number bonds. I have 8/8 plus 8/8. So that's 8, 16. Then I have to figure out the difference between 22 and 16. 17, 18, 19, 20, 21, 22. It's 6. So we have 1 whole, 2 whole, plus 6/8. So this would equal 2 and 6/8. And if we watch that one video about the improper fractions and proper fractions and mixed up numbers, we could also simply do this. 22 divided by 8. 8 times 2 is 16. We subtract. 12 minus 6 is 6. 1 minus 1 is 0. So here we would have 2. The quotient is our whole. The remainder is the numerator, and the denominator doesn't change. So 2 and 6/8. Just another way to go about it. Okay, let's add up 7/8 and 9/8. I have a feeling this one will be fun. We have 7/8 plus 9/8. And what will that equal? Well, I know the 8 remains the same, right? The denominator does not change when we're adding and subtracting like this. So 7 plus 9, well, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I bet you're saying to yourself, I know the answer. Well, think about it. 8 times what is 16? And 16 divided by 8 is what? Remember we were doing those sentences? So 16 divided by 8, and 8 times the number equals 16. What's going to fit there? What number? Well, 8 times 2 is 16. So 16 divided by 8 must be 2. And then our answer right here is 2. Because remember, fractions are just division. 16 divided by 8. Let's make some subtraction sentences now. And let's do 15/8 minus 7/8. I know this is greater than 1. I know this is almost 1. Let's see what happens, what we get. The 8 remains the same, right? And then 15 minus 7 would be what? 15 take away 7 is, we go 15, 14, 13, 12, 11, 10, 9, 8. And what would that equal? Of course, we know when the numerator is the same as the denominator, it equals 1. All right. Now let's do one more subtraction sentence. Let's do 9/8 minus 7/8. Greater than 1, right? Almost 1. 8 stays the same, and 9 minus 7, 7, 8, 9 is 2. So we get 2/8. So we see we had 9/8, and we took away 7, we get 2/8. All right, let's go to the next part of our work, or problem set. It says solve, model each subtraction problem with a number line and solve by both counting up and subtracting. Part A has been done for you. Okay, so we look at part A, because some of you don't have the problem set. It says 1 minus 3/4. So how do we figure this out? Well, we turn this into a fraction. What would we turn the 1 into? Think about it. We're dealing in fourths, so when we turn it into 4/4 and we subtract 3/4, doesn't look so difficult now that we do that. And so 4 minus 3 is 1, and we get 1/4. And let's go ahead and make a number line. So over here we have 0/4, then we have 1/4, 2/4, 3/4, and 4/4. So what we did is we started out with 4/4, and we subtracted all the way down here, and we got 1/4. But we're going to show this through addition. We're going to say 3/4 plus 1/4 should equal 4/4, right? There's 3/4. We're going to add the 1/4, and we get 1 whole. So it's just the opposite, right? 4/4 minus 3/4 equals 1/4, or 3/4 plus 1/4 equals 4/4. Kind of confusing, I know, but we'll get the hang of it. Let's do the next one. It's 1 minus 8/10. What will that equal? Well, we could just make this into 10/10, right? Minus 8/10 equals what? Well, 8, 9, 10. That would be 2/10. And let's prove it on a number line using addition. So I'm going to make 10 notches. There's 0/10, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10. I'm going to go ahead and label those. 0/10, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10. So we started out at 10/10 and we subtracted 8. 1, 2, 3, 4, 5, 6, 7, 8. And we got 2/10 right there. However, let's use addition now. Let's do 2/10 plus 8/10 should equal 1, 2, 3, 4, 5, 6, 7, 8, 10/10. So I know that 10/10 minus 8/10 equal 2/10. So you can see that 2/10 plus 8/10 would equal 10/10. And we'll continue on with our next one. And it is 1 minus 3/5. So we're going to turn this into fifths. 5/5 are 1 whole minus 3/5. And I think you've all got it down. You know the denominator does not change. And 5 minus 3 is 2, so that gives us 2/5. Now, let's make a number line out of this. We have 0 and 1. So 0/5, 1/5, 2/5, 3/5, 4/5, and 5/5. So I'm going to label these 0/5, 1/5, 2/5, 3/5, 4/5, and 5/5. Now, in the subtraction realm, we started out with 5/5, and we minus 1, 2, 3. We got 2/5, but now we're going to do addition to prove ourselves correct. I'm going to start out at 2/5, and I'm going to add 3/5. 1/5, 2/5, 3/5. What do we wind up with? You bet you. We wind up with 1 whole. Okay? And let's go on to our next one. And it's letter D, and it's 1 minus 3/8. And that will equal what? We're going to turn this into 8/8. I'll do this right over here. How about save a little room? 8/8 minus 3/8. So we know that the 8, the denominator does not change, and 8 minus 3, 7, 6, 5 is 5/8. Let's prove it using yield number line. And we're going to make this into 8s. 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Let's label them. Remember, you can always pause if I'm going a little too fast. 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. Okay, so there you have that. Now, we took the 1, we subtracted 3/8, and we got 5/8. 8/8 minus 3/8, 1, 2, 3 is 5/8. So if we add the 3/8, we should wind up at 8/8. 1/8, 2/8, 3/8. And there we have it. Plus 3/8 gets us right where we need to be. 2 more to go, and they're going to get a little trickier. So we have 1 and 2/10, a mixed number, minus a proper fraction 7/10. How in the world are we going to do this? Well, there's a couple of ways we could go about it. Let's look at one way to start out with. I can go, okay, I have 10/10 and 2/10, right? So I'm going to break this apart to 10/10 and 2/10, right? 1 whole and 2/10. That gives me 12/10, right? So this will equal 12/10 minus 7/10. What do I get? 12 minus 7 is 11, 10, 9, 8, 7 is 5. And the 10 doesn't change, so we have 5/10. And you're thinking, wow, Mr. Leggett, how in the world does that work? Well, let me show you. This number line is going to be a little bit longer. We have to make 12/10, right? So 1/10, 0/10, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, 11/10, and 12/10. Okay? So we're going to start with 0/10, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, 11/10, and 12/10. Okay, so we had 12/10, and we subtracted 7. 1, 2, 3, 4, 5, 6, 7. What do we wind up with? We wound up with 5/10. So let's prove this using addition. We're going to add that 7/10. 1, 2, 3, 4, 5, 6, 7. And look, boo! I can go right there and say plus 7/10, and I know I'm right using this method, and this method. Now let's do our last one. We have 1 and 1/5 minus 2/5. Okay? 1 and 1/5 minus 2/5. Let's break this down into 5/5 for the 1 whole plus 1/5, right? What do we get? 5 plus with 1/5 is 6/5. And we just subtract 2/5. By now, I hope you know the denominators do not change. It's going to stay the same at fifths. And 6 minus 2 is 4. Let's prove this in a number line. 0/5, 1/5, 2/5, 3/5, 4/5, 5th, and 6/10. Remember, 6/5, excuse me, not tenths. So you have 0/5, 1/5, 2/5, 3/5, 4/5, 5/5, and 6/5. Okay? Then we subtracted the 2/5. 1, 2 to get 4/5. It looks like we're right there, right? But now let's use addition to show that we're right. We're going to add 2/5. And it proves that we are indeed correct. Make sure you do your IXL 25 minutes and your Imagine Learning 25 minutes. And I think some of you are watching the video, but you're not taking the quiz that follows. So be sure to take the quiz that follows. And also check out Language Arts today and Social Studies. Thank you very much for being a wonderful audience. I hope to see you real soon. And I will talk to you later.